Okay, so this is the momentum and collision problem. It says that we have a snooker ball of mass 240 grams. It's initially at rest and the player strikes the ball with a cue, delivering an impulse 0.84 Newton seconds to the ball. Calculate the velocity of the ball after it's hit. Okay, so the first part of this question is looking at impulse, which is how force is related to the change in momentum. So we can write down some of the numbers that we know. We're told that the mass is 240 grams, so that's equal to 0.24 kilograms. The initial speed is 0. And we're told that the impulse, which is force times time, is 0.84 Newton seconds. The equation we're going to use is that impulse is equal to the change in momentum. So that means that it's equal to the final momentum minus the initial momentum. And this is 0 because the initial velocity is 0. So that gives me that the impulse is equal to mass times the final velocity. So I can rearrange that to get my velocity is going to be the impulse divided by the mass. So V is equal to 0.84 Newton seconds divided by the mass, which is 0.24 kilograms. So putting those numbers into my calculator, I've got 0.84 divided by 0.24, which gives me a velocity after it's hit of 3.5 meters per second. Next question, the ball goes on to collide inelastically with a second ball of the same mass, which is moving at this speed in the opposite direction. State is what is meant by an inelastic collision. So in an inelastic collision, kinetic energy is not conserved. So kinetic energy is not conserved in an inelastic collision. Question 3. After colliding, the two balls move off in the same direction. The speed of the leading ball is twice that of the ball that follows. Calculate the velocity of the leading ball. Okay, so we had this situation before, where we had ball 1 and ball 2. This one was moving at 3.5 meters per second. This one is moving at 0.75 meters per second, and it's moving in the opposite direction. So the arrow should not be shown like that. The arrow should be shown like this. And then it says that after colliding, they move off in the same direction, and we want to know what the speed is of the leading ball. So after, we have ball 1, ball 2, they're both going in the same direction, and it tells us that the leading ball is twice the speed. So if its speed is V, the speed of this one is V over 2. Okay, so it's an inelastic collision, so kinetic energy isn't conserved. However, momentum is always conserved. So using the fact that we know that momentum is conserved, that means that momentum before is equal to the momentum after. So the momentum before, we have this ball, which has got a momentum of 0.24, its mass, multiplied by its velocity, plus the momentum of this one, which is also 0.24, times its velocity, and its velocity is in the opposite direction. So I put in a minus sign. So that gives me that the momentum before, which we can call P, I'll put in a little subscript b for before. That's going to be equal to then 0.24 so that gives me the total momentum before is 0.66 kilograms meters per second. After, oops, well, what have I got? Afterwards, I've got the first one, so it's 0.24 times v over 2, plus the second one, which is 0.24 times v. So that gives me that the momentum afterwards is equal to 0.24 times 3 v over 2. Now we can say, because momentum is conserved, we can say therefore that 3 times 0.24 v over 2 is equal to 0.66. So that gives me that 0.36 v is equal to 0.66. Putting that into the calculator, I've got 0.66 divided by 0.36 gives me a velocity of 1.833 recurring. The velocity is equal to 1.83 recurring. Now in physics, we never use this. We never write something in recurring. We always round it. The numbers that we've been given in this question have all been to 2 decimal places. So we're going to, because here we have the velocity 0.75, the mass 240 grams. So we've, I beg your pardon, 2 significant figures, not 2 decimal places. The numbers have all been given to 2 significant figures. So we have to give this answer to 2 significant figures. So our answer is going to be 1.8 meters per second. Then part 4, after the collision, the leading ball falls into a pocket that's 84 centimeters from the point at which they collided. Calculate the maximum size of the average frictional force. So what they're saying is this is the leading ball now, ball 2. We know this is traveling at 1.8 meters per second. And we're saying that 84 centimeters away, that's where it's going to fall into the pocket. And so we know that it covers that distance. We said that there are frictional forces, so there is going to be some deceleration in this direction. Okay. However, we know that the ball has to reach the pocket to fall in. Therefore, the minimum velocity at 84 centimeters is 0. So for it to fall into the pocket, it has to at least have reached where the pocket is. So the minimum velocity you can have at this point is 0. So we can use that, and this essentially then becomes a suvat question. We've got the distance is 0.84 meters. The initial velocity is 1.8 meters per second. The final velocity is 0 meters per second. We're looking for the size of the force, and to be able to work out the force, we need to know what the deceleration was. So this is what we want to know, and we don't know what the time is. So which equation do we pick given these 4 things? Well, it's going to be v squared equals u squared plus 2as. So that gives me, putting in the numbers, I've got that 2 multiplied by a multiplied by 0.84 is equal to minus the u number squared. So that gives me the value for a is equal to 1.8 squared divided by 2 divided by 0.84. That a is equal to 1.93 meters seconds minus 2. And then we can use F equals ma. That gives me the force is equal to the mass, which is 0.24, multiplied by 1.93. Gives me an answer of the force is 0.4632 newtons, and again I'm going to round that to two significant figures. Now, sometimes it can be a little bit tricky in questions to know whether we should use precise values or rounded values. If we look at this question, this is the value I get because I used 1.8 for the acceleration. If I was to use the original full precision of the value that I get, so there I would have that A is equal to minus 1.83 recurring squared divided by 2 times 0.84. That would give me an answer of 0.48 newtons. Well, it'll give me an answer of, for the acceleration, it would give me an answer of so that would have given me an answer of minus 2.0 meters seconds minus 2 to give me a force answer of 0.48 newtons. So generally speaking, if we're making a series of steps within a question, then we would keep the full precision. Very often in mark schemes, they will allow either of these answers depending on whether you use the rounded value or the full precision value. The thing you might notice is here I've written this as minus, so that should be minus, and again, strictly speaking, this is a deceleration, so I should have kept the minus sign in there, and the minus sign for the force here, meaning that it's telling me that the force is working against the direction the ball is moving. However, we can see that the question asks for the magnitude, so we don't need to put the sign in there, we're just looking for the magnitude.